Hello and welcome to another episode of That Fabric Guy here on YouTube. I am your host Bas Land and I will be teaching you about Microsoft Fabric every week for free. So let's watch this video and see what I have in store for you. Alright, a couple of weeks ago I was showing you how we can use DuckDB as a Python library in Microsoft Fabric in order to do Python notebooks on Delta Lake instead of using Spark notebooks. And the benefits of using Python over Spark is that Python is more lightweight. Your session startup times are much lower, so your sessions will start up faster. And these notebooks will use less compute resources than a Spark notebook. So for smaller data sets, it's actually very nice to use DuckDB in Microsoft Fabric. However, what I didn't show you and what I found out the other day, and I am showing you today, is how we can actually change the settings, the number of compute power, the vCores and memory that we can get inside a Python notebook in Microsoft Fabric. So let's dive into my laptop and find out. Alright, here we are looking at my laptop and we are already in a Python notebook, and we can see that right here that we are running in a Python language, and Python here is ticked and not Python PySpark. So that's how we can see visually that we are looking at Python. Now what we have here is the very simple demo notebook that I showed you the other day, where I was demoing DuckDB. So we're still doing the same thing. We import DuckDB, we connect DuckDB, and then we attach basically a table from the lakehouse to DuckDB. And from there, I wanted to do a count star. Now what I want to show you is the following, and that's right here on the bottom of the screen. It's maybe a little bit hard to read, but what we see here is that we have CPU 2 vCores and RAM 16 gigabytes. And now we're only using 2.6% of our CPU and only 14% of our memory. And actually when we click on this button, it's a button, we will find that we get a graph where we can see our CPU usage over time and our memory usage over time. Now what I want to show you today is how we can not only find out bottlenecks in our notebooks using this graph, but also can increase the compute power that we get with our Python notebooks. So first of all, I've created a table that contains about, I think, 75 million rows, and I will be loading that into DuckDB and then doing a simple count star on that table. So let's run all and see what's going on. And as you can see here on the right side is that my CPU usage is already increasing quite a bit. We're hitting 100% CPU utilization at the moment. And in my testing, I was expecting about 40 to 50 seconds to actually load this table, this subset table into DuckDB, while using almost all of our memory as well. So we're coming from less than 2 gigabytes consumed, and we're increasing now percentage-wise almost to 100%. And now we can actually see that we're done, and right before this cell was completed, we saw the CPU usage dropping quite a bit. Memory usage still at an all-time high, and indeed in 40 seconds we have now created the DuckDB connection, and we're now running a query to find the row count in this table. If we scroll down a little bit, here we find that we have 75 million lines in this table, in a total of about a minute where we found this time, 40 seconds to do the connection and then 16 seconds to run the query. Now as you can see that there was a large bump here in our CPU usage, and then our memory usage keeps on going basically. So how can we actually increase the hardware, the performance that we get in our Python notebooks? So what we can do here is put in a cell that is a configuration cell. So putting in the double percentages or the magic command configure, and now it autofills quite a lot. We're not going to do that. We do configure -F and we remove all of this. I didn't mean to put this in, and we type vCores, it's in multiple, and we type in, I don't know, 64 is the highest that we can go, I think. So we can go 4 up until 64, I believe. Maybe we can go higher, I don't know. If, according to the documentation, we can go to 64. Now let's run this cell, and we get an error. Why do we get an error? We are now basically asking to create a Spark node, a server. And yes, we're not running Spark, but we are getting a single node server basically to run Python in. And we're asking to do that in the extra large node size on our small little Fabric F2. And now this F2, of course, is way too small to get this much hardware. So what do we have? We have our concurrency limits right here. And today we are working with an F2, and you can see here that we get a maximum of 4 spark cores. Now with an F32, we can get 64 spark cores, and maybe we can go higher all the way to 4096 spark cores on an F2048. So let's see if we can actually get an an F32 with 64 vCores here. So let's go to my portal here, go to scale and change size on my demo capacity. And let's put in the 32 right here. There we are. And now we go back to the notebook and try to run this again. Okay, apparently we're still on an F2. I think we do need a little bit of time in order for the engine to catch up that we are now actually upgraded to an F32. I tried it again, and since the cell is now running for a bit longer than I expected, I mean, we're not getting an error, I think we are now actually getting a larger node size. So let's see how long this takes, and let's see how fast our queries then become. Also, we will be getting more memory. So what Fabric will do is we will be getting 8 gigabytes of memory for every vCore that we have in our system. So with the 2 vCores, we got 16 gigabytes, and with 64 vCores, I will expect to get 512 gigabytes of memory for my Python session. It does take a while though. I'm not sure why this takes so long. All right, here we are. The session is now started, and we do have additional vCores. And here on the right side, we still see 2 vCores and 16 gigabytes. Here on the bottom, we see 64 vCores and 512 gigabytes already. So maybe we need to remove that and click here again. And now indeed, we can see that we have way more cores than we had before. So let's start the connection and the query again and see what's going to happen. Okay, DuckDB is not defined. I need to run this again because I think the kernel got restarted. So let's import DuckDB again and then run the connection and the mapping again. Now the CPU usage is growing. Memory usage is growing as well. And let's see if we are actually going faster. And yes, we are going much, much faster. So we're now in 15 seconds as opposed to consuming 40 seconds. So we're almost 3 times as fast. Now the query itself was not that much faster. Maybe that's a single threaded process, I don't know. But at least we're now getting an answer in total that is way faster. So do we have a way that we can make our processes in Python faster? Yes, we can. We can allocate more hardware, basically more resources to our Python notebooks. And that will speed up our process. However, we need to keep in mind that going here to our concurrency limits, we only get so many vCores for a given Fabric SKU. So always check this table if you want to find out how many vCores you can actually attach to your Python notebook.